What's up, guys? Welcome to your first lesson of the chapter on equations. And let's just go ahead and tie in what we did in the last chapter with what we're going to be doing in this chapter. In the last chapter, we dealt with what were called expressions. And an expression looks like this: 2 plus 3. Right? And it's just a statement, basically, mathematically, saying we're going to add 2 and 3 together. Right? Well, equations are a little bit different because equations are also a statement, but they state that two things are the same thing. They're equal to each other. You might see an equation written like this. Equations have equal signs, and then to complete this statement, to make this true, we would put a 5 here. And we could say that 2 plus 3 equals 5. And this is what an equation is. It literally says that on either side of this equal sign, that we have the same thing. 5 over here is equal to the same thing over here, right? 2 plus 3 is 5. Well, over here is a 5. These are the same thing. That is what an equation is, okay? And that's the most important thing to get in your head to start off this chapter. Now, that is a numeric equation. That means there's only numbers in it, right? And that was a pretty easy one. But now we're going to have algebraic equations, okay? And I guess there's one. Algebraic equations have letters in them, okay? And we're going to get to that in a second. But there's one more thing I want to make sure that is clear, especially for this chapter here. Let's take a very basic equation like 5 equals 5, okay? No one can argue that this isn't true, right? And that's what's really important. The word truth, right? True is really important in what we're discussing today and in these lessons with equations, because it has to be true if it's equal, right? 5 equals 5 is a true statement. Now, I want to make sure you guys understand something. And that's all we care about is the truth of it. Is it true? If I were to say take 3 away from this side of the equation, would this statement still be true? And the answer to that is no, right? Because if I took 3 away from this side of the equation, that would give me a 2, and then my statement would be 2 equals 5. And that's not a true statement, and therefore not true, right? So we can't do that, right? We want to make sure the statement stays true. So are we allowed to take 3 away from both sides, or from this side? No. Are we allowed to take that same equation, 5 equals 5, are we allowed to take 3 away from both sides if we wanted to, right? And we're kind of just exploring, like, what are we allowed to do here? Is this statement true? Yes. We are allowed to do basically anything we want as long as the statement stays true. If I take 3 away from the one side, like in the last problem, it wasn't true. What if I take 3 away from both sides? Then I get 5 minus 3 is 2, and then 5 minus 3 over here is 2. This statement is still true. So the question is, am I allowed to subtract 3 from both sides of this equation? Will it keep it true? Absolutely. And that's a cool thing that we need to understand going into today. So our equations today are going to look very similar to this. We'll start off with, they're going to look something like this, right? My first example was 2 plus 3 equals 5, just a basic equation. That's true. But I might actually just take one of these numbers and turn it into a variable. For example, instead of 2 plus 3 equals 5, I might say x plus 3 equals 5. And many of you guys asked me in the last chapter, like, can we figure out what the variable is? Well, you couldn't in an expression, but in an equation, because we have to make sure the statement is true, we can figure out what the variable is. There is only one number that could possibly go here that makes this statement true. And if you can figure out what that number is, then you have the answer to your equation. And this one, hopefully you know that mentally, something plus 3 gives you 5. You might already know that that's 2. But what I'm going to show you today is a way to solve all of these equations like this, addition equations, without having to just do it with guessing or mentally. Here's an example. C plus 2 equals 5. You probably already know what this is, right? Something plus 2 will give you 5. You probably know that C is equal to 3, which it is. But check this out. And this is really important to learn how to use. What I just showed you about your ability to subtract the same thing from both sides of an equation and still make it true really helps you solve these types of problems. Watch this. If C has a 2 being added to it, I can actually do the inverse of that and subtract it away from it. Check this out. If C right here, which we don't know what it is yet, has a 2 being added to it, I'm going to subtract it. If I do that, I must do it on the other side of the equation to make sure it stays balanced because it's super important. I got to keep the statement true. Right? And like I did earlier, I'm allowed to subtract 2 from both sides. It'll keep it true. I proved that. If I do that, watch what happens. What happens if I do a plus 2 and a minus 2 together? What is 2 minus 2? Well, it's 0, right? It cancels out. Right? 2 minus 2 is 0. So what's left on this side of the equation is just C, which is kind of cool because if I only have C left over here, that's just C and then my equal sign. And then over here, 5 minus 2 is 3. And if you already knew the answer to that, absolutely the answer is 3, right? And it's really cool how using this subtraction property of equality can really help you solve these problems. Let's try another one. I bet you can do this one in your head. 6 is equal to x plus 5. Could you figure out what x is? I'm sure you could. Let's see if you can use that subtraction property of equality to help balance out this equation and figure out what x is. Well, if x has a 5 being added to it, I can actually just subtract 5 away from it, and that's going to isolate this guy. It's going to get him all alone, which is a really cool thing because if x is all alone, then it tells me x equals something, and that literally tells me the answer to the problem. But if I subtract 5 from this side, I have to make sure I do it from the other side too to keep the statement true, right? Keep it balanced. So 6 minus 5 on this side gives me 1. So I have an answer of 1 equals x, or x equals 1. You can write it this way to be a little bit better. Which you probably knew what the answer to that was, but what we're really trying to practice here, guys, and this is super important, getting this variable x alone right there. It's called isolating the variable. Super important. And we do that by getting rid of the stuff around it. Like since it's x plus 5, we do a minus 5. We do the inverse operation, and then it gets the equation balanced, tells what the answer is. Now, obviously we could do this with decimals and things too. Oh, it works the same way. 3.5 plus something gives you 12.75. And now you're going to see why it's so important to be able to do this, because this one might not be one that you can do in your head so easily. For me, it's a little bit easier because I've been practicing this a lot. But what you should do here is the exact steps I've been showing you. We noticed that y here, what we're trying to figure out. And if we can get this guy alone over here on this side of the equation, it would literally say y equals, and then whatever number we get here is the answer, right? Y equals that. That's what it is. And in order to do that, we need to isolate it. So we have a 3.5 here, and if we take 3.5 away from this side, then that just cancels it out. That's 0, which is really cool because it gets the y alone. But remember, you have to then subtract it from this side too, minus 3.5 from this side. I'm going to line up my decimals because that's how you subtract and add decimals. And then go ahead and subtract here. 5 minus 0 is 5. 7 minus 5 is 2. The decimal. And 12 minus 3 is 9. And your answer is that. All you had to do was subtract 3.5 from both sides of the equation, and it literally tells you that y is equal to 9.25. And it is. 9.25, if you put it in here, plus 3.5 will give you that. Some quick tips on helping you solve equations in word form here. Ruben and Tariq have 245 and a half downloaded minutes of music. If Ruben has 132 minutes, how many belong to Tariq? So basically what we have here is we have them together. Their total is equal to Ruben's songs plus Tariq's songs. Right? Now, I've done no math yet, right? No numbers anyway, but I have started the math, right? I've tried to show an equation here, but their total number of minutes, downloaded minutes of music, is equal to both of them together. Okay? Well, we know what the total is. It's 245.5, right? So it says it right there, total minutes of music. Ruben has 132, so I can put that in for Ruben, 132, and add that to Tariq's, which we don't know. So we can actually keep Tariq's a variable. And here we have just a basic equation where if you can figure out what that 132 plus something gives you that, you know the answer to your problem. And if we follow the rules that I've just shown you, get the t alone by getting rid of this 132, if we can cancel this out, then we can find our answer. How do you cancel out a 132? Well, you subtract it away. 132 minus 132 is 0. Which means if we subtract 132 from this side, we should get our answer. Subtract here. Looks like Tariq downloaded 113.5 minutes of music, just like that. Isolating the variable. Get the letter alone by getting rid of the stuff around it. And in this case, you have to subtract to get rid of it. Last problem. It takes 43 facial muscles to frown. That's a sad face. This is 26 more muscles than it takes to smile. Write down and solve an equation to find the number of muscles it takes to smile. Okay. Well, in this case, we've got a total muscles it takes in the face to frown. Right? So we take total for frowning, and that is equal to 26 more than what it takes to smile. We don't know what it takes to smile, so we take S plus 26. Okay? So what we have here is the total number it takes to frown, which is 43, and that equals what it takes to smile plus 26. So, and if you can figure out what plus 26 equals 43, then you find out how many muscles it takes to smile. And in order to figure this out, isolate your variable. Get the S alone by getting rid of this plus 26. How do you get rid of plus 26? You minus 26. You minus 26 from this side as well, and you'll find out that the muscles it takes to smile, 43 minus 26, that is 17. It takes 17 muscles to smile, and it takes 43 to frown. If you've got questions about these addition equations, let me know. I'm going to be using a lot of the same terminology as we have in the last chapter. Should be a nice, smooth transition here. Just might need a little bit of practice with some decimals and stuff, but other than that, let's get to it. Have a good day.